Welcome back to another exciting chemistry lessons. In the previous lessons, we looked at chemical equation that used to describe chemical reaction. Now, in this lesson, we are going to look at chemical equation to look at the law of conservation of mass, or the law of conservation of matter. Based on this law, the atoms are neither destroyed nor created during a chemical reaction. Basically, the number of atoms for each element is going to be the same on both sides, the reactant side and the product side. Now let's look at this example. In this case, we have this chemical equation right here. We have silver oxide produce silver and oxygen. In this case, what we have here is this arrow here divide the reactant side and the product side. So on the reactant side, okay, what do we have? Well, what's 2 times 2? This is your coefficient right here. 2 times 2 is what? 2 times 2 is 4. Do we have any more Ag on this side? We don't, so that's all we have. Well, what about the oxygen? Well, 1 times 2, that gives us 2. So on the reactant side, we only have 4 silver and 2 oxygen. Now let's go to the product side. We have Ag, and it doesn't have a coefficient, so it assumes it's going to be 1. So 1 times 1 give us what? Just 1. What about for oxygen? There you go. We don't have a coefficient, so 1 times 2 give us 2. Now, based on this chemical equation, we are going to answer the following question. Is the equation balanced? Of course, no. If it's balanced, I mean, think of the word balance like equal, okay? So if it's balanced, you will see the number on both sides the same. In this case, Ag has 1 on the product side, but has 4 on the other side, so it's no. Now, if it's not the same on both sides, so therefore the mass on both sides would not be the same as well, so therefore no. Now, are the number of atoms for each element on both sides the same? Of course, is no. Does it follow the law of conservation of matter? Of course, no. So right now, because it is not balanced, it does not follow the law of conservation of matter. Now let's try another one where we are going to look at this more carefully in terms of, does this equation follow the law of conservation of matter? We have nitrogen here. Again, there's nothing there, so we assume it's going to be 1. What's 1 times 2? 2. Now, we don't have any more nitrogen, right? So again, this arrow divides the reactant from the product side. So in this case, we have 3 times 2, that gives us 6. And we don't have any more hydrogen. Over here, we have 2 times 1 gives us 2. And 2 times 3 gives us 6. Now, based on this information, we are going to answer the following question. Is this equation balanced? Yes. How do you know it's balanced? Again, the word balance, think of this as an equal sign. So therefore, both of them are the same. If they have the same number of atoms for each element, of course, the mass is going to be the same as well. Now, are the number of atoms for each element on both sides the same? Yes, right there. Does it follow the law of conservation of matter? Well, based on this chemical equation, yes. And that is how you interpret if a certain chemical equation follows the law of conservation of matter.